Welcome to Running on Ice, the coolest community in freight. I'm your host, Mary O'Connell, bringing you the latest tech updates, warehouse news, and everything happening in the cold chain world. Not only is there the coolest show in freight, but there's also Running on Ice, the newsletter that could not be colder. You can subscribe to that on freightwaves.com/runningonIce. Today, we welcome Saeed Al-Hallaj, Chief Battery Scientist at Beam Global. Welcome to the show.
Thank you for having me.
I am excited to get into this because this is something that we have honestly never really talked about before. We've talked about different ways to power reefer units and different stuff like that, but we haven't actually gotten into like the battery science behind it. And for that, I'm excited. But before we get too far into that, let's get some background on you and how you got started at Beam Global.
Yeah, so I actually joined the Beam team about a couple of years ago when they acquired my battery company, also Technology. But I've known the team for over 10 years. I used to provide batteries for all kinds of Beam products.
It always blows my mind every time we get into like one of these little niches of industries that like power other industries, because I didn't even think about batteries being like a thing that reefer units and other things need, because you just don't think about it until you're sitting there dealing with it. And I'm excited to get into some of the unknown today. But recently, Beam kind of announced this new product, Beam All Cell. Do you mind breaking that down for us and kind of explaining what it does and why it's a little different from some of the other batteries?
Yeah, so actually we're excited because one of the things that you will see in a lot of the innovations today, most of it, it's wireless, but a lot of it's cordless, which used to be a thing for phone, but now everything is from personal electronics to mobility, everything needs batteries. So we're excited, and with the growth of renewable energy and the resilience of all that, energy storage, which is batteries, becoming a key player. And what we're focusing on is a lot of these cool applications. Think of robots, autonomous vehicles, drones. The next time Mary comes to Chicago, we'll get you in an air taxi from O'Hare to downtown or to our Beam facility. So all that need batteries, and that's where we come in. We love to talk to people who are inventing all kinds of stuff, and they need batteries. Typically, the batteries they need is not something you buy off the shelf, and that's where we shine. We provide really cool solutions, and our logo is it's cool by design because that's our approach to it, which combines technology, really cool engineering, and then state-of-the-art manufacturing.
I think that is a very good way to put it, because you guys, again, do make things that aren't off the shelf. Because last time I checked for like an electric powered forklift, you can't just like shove it full of double A's or a 9-volt and expect it to run.
Yes, yes. I mean, some of those are actually, something is actually more cool. Or think of it that when people design these cool equipment, some of the stuff that you see, drones, robotics, some of the personal vehicles, the last thing they think about batteries, they finish, inventing it, like, okay, here it is, fit the battery here. Like, okay, wait a minute, can we have a chat about it? But it's an afterthought, but we love that. We love to work with people who want them to focus on their innovation and let us worry about the battery.
100%. And it's kind of that thing that I always come back to is, knowing what you're really good at and knowing what your core business things are. So like if you're known for building fantastic machinery and other stuff like that, that's great. You don't need to become a battery expert. There are people who are battery experts. You just need to call them because they're going to have the answer versus you sitting there trying to revolutionize the battery world or like cram some pre-existing thing in there that's not actually the right solution.
Yeah, absolutely. And we love it when we go to shows and when people call us after reading some of our patents or papers and they say, look, I have this idea. I know it's crazy and may not be able to be done, but can we chat? And that's the best line that I ever hear. All right, that is something exciting. If something that, it's not intuitive and, it's not something that you can just say, oh, it's easy. If it's difficult, if it's challenging, we love to work with you.
I think that's like a true test of like any engineer is you walk up to them and go, I have this crazy idea. And they're the first ones to go, it's not crazy, but tell me more.
Tell me more. Exactly. Exactly.
So for this new beam all cell, kind of how does the installation of it work? Like, do you have to, can you, is it something that you have to design around for? So like you can't just say, I need three beam all cells and then you can plug them into whatever you want, or is it kind of a new battery that you design something around?
Yeah, so for the last 20 years, we've been very successful in building, I would say lightweight, compact, high performance batteries. And safety is always our number one priority. In the last few years, we started noticing that that's not enough. So, people want smart integration. It's something called battery management system. They want it to be beside the function to protect the battery and tell you the state of health. They want it to do more stuff. For example, they want to know, how can I charge in cold condition? How can I charge in hot condition? How can I, if I have a fleet, how can I program it to use, something like machine learning or artificial intelligence to be able to, check on the battery, see what state of charge, state of health, and use it as part of optimizing the fleet as a whole. And those are the things that we started working on. Beside the material improvement that we, innovation, battery design and engineering, we started looking into more into, I would call it the intelligence, to combine battery thermal management with engineering and be able to actually know what's going to happen to the battery before it happens and let the owner know so they can plan and do their stuff to optimize their operation. And again, we want them to feel that the battery is the last thing they should worry about the good stuff that let us take the battery, and the battery will be equipped with the intelligence and the communication and the proper, I would call battery management system to help them, ensure safety, cycle life, but performance.
So, I have a question on how you test safety. And this is my favorite question of everyone who has to go through this R&D process of figuring out, okay, well, how cold is too cold? How hot is too hot? Um, have you ever, because you want to make sure the batteries are safe and like can take a bump. You want to make sure that they're able to survive. What were some of the cool tests that you put the batteries through? Because obviously, you have a patent on it, which we'll get into that in a little bit, but you have to prove its safety. So, like, were there any fun tests you did to prove its safety?
Yeah, I hate to admit that, but actually my favorite part is blowing up batteries, literally.
In a very safe, controlled environment.
Absolutely. That's, of course. Do not attempt at home, right? So we actually, when we started this research, there's actually devices or equipment that is designed to literally figure out what is, I'm a chemical engineer. So for example, when you have a reactor, you want to know when it's going to blow up, what are the combination of temperature, pressure, and reaction to actually design for it, to design a safe reactor. So we took one from that book. Literally, there's a device called accelerate rate calorimetry, which literally heats up the battery and start looking for stuff. And if when it happens, it monitors and then you record everything bad and you design for it. So it's 101 for us. Every cell we acquire or we include in power design, we blow the heck out of them at different temperature, different state of charge, different oil condition. We charge them when they're cold. We charge them when they're hot to really push. We call it abuse testing. So, but the reality is to really identify, quantify, and understand every failure mechanism to be able to design for it. And once we're done with the cells, we start then implementing on the pack, and we repeat the same thing on the pack level. And that's when it becomes actually, sometimes we don't do it in house, sometimes we do it at specialty labs. And these are dangerous. Like if I show you, I don't know if you saw one cell fails, which is like a little bit bigger than double A. You can see a torch coming out of it and it hits and melts steel. And actually, unfortunately, there were some deaths in cases when people use them in not a proper way for vapors. And there were some cases. But when you put those together, you're talking about a grenade or even bigger. So it has to be very well, controlled environment. But again, we do that because we want to do two things. Number one, we want to understand the mechanism of failure so we can design against it. But the other thing is the best test that we have is when nothing happened. And that's when our customer is happy. We put it in, we throw out everything and, little the kitchen sink. And we show that, that we, for those design conditions, that our battery will be safe.
I think that some of those stories of like hearing, because like we've had people who have built kind of like a ruggedized thing, and they've like brought in a 70-foot like fire truck ladder and threw it off the top of it. Someone else ran it over in like their pickup truck. And I love hearing the stories of just like, we're going to try to break it so we know where it fails. So we know just because like people know just how far their customers are going to push it to the limit. And so I love that. I think it's fantastic, and I just love hearing some of the stories of it. And I do think that might be one of the coolest jobs, is to sit there and say, and to be one of those testers for any product. But apparently it's not exactly the easiest job to get.
You know, it's funny because when I used to do these tests, I would get too excited, and I said, and my staff like, get the heck out of here. You know, we don't, because I get too excited. I want to do stuff, but you know, it's amazing that how much people who actually do this stuff are trained, very well trained, and but it's exciting to see that, you know, we can actually, because one of the things that, you know, any industry is, it's a balance. For us, we thrive on making battery safe and, you know, touting that we you know, we can do battery safe. But if these things happen, you know, could threaten the whole industry. It's like, wait a minute, no, there is a danger like everything else. We're not denying, but we can take care of it, and we can design for it. So yeah, it's always interesting as an engineer, as a scientist, to see something that is challenging, that people are worried about, and be able to share, look, we've done it, come and check.
Like, if you can think of something that we haven't already put this through, let us know because we'll do it. So that safety and that engineering that has to go into part of the patent that comes from this all cell product, because I mean, you guys have quite a few patents on things. But can you kind of like explain a little bit more about that technology behind it?
Yeah, so we started actually 20 years ago. That's when these patents started. And we started around the concept of, you know, protecting the batteries using phase change concept, which, think of it like an ice, you know, ice cube. If you put in a lemonade, glass of lemonade, it will keep it at 0 Celsius or 32 Fahrenheit until the last ice cube melts. And during that process, it absorbs a lot of the energy. So actually, that's exactly what we do. We surround the material, the batteries, with a phase change composite, which is our material, that absorb the heat and move it around to make the battery uniform and safe. But as we started moving toward, you know, manufacturing scale, we started expanding. So we started having patents on how to manufacture this material, patents on how to integrate it with mechanical, with other thermal solutions. And as I mentioned earlier, also how to integrate it with battery management system, communication, electronics, predicting all that stuff. So, I mean, we're sitting right now. It's fun. I started looking the other day. Someone asked me like, well, "Now, can you tell?" We had to do inventory. So I was looking at the papers. My gosh, like we had published over, I don't know, 50 to 100 papers, conferences, and all that. And we have over, I don't know, tens of patents over the years. And each one of them had a story. And I start thinking of like, man, we should sit and talk, because we would be in the lab and we'd like, okay, we have a problem, you know, how to do this. And we come back, you know, a few days, a few weeks later, like, oh, look, here's it is. Let's go test it. And then you file for a patent. And it's like everybody's story. And it's fun when you're, you know, for scientists and engineers, that's the fun part, to, you know, troubleshoot problems, solve them, and come up with a solution. And the patent is a nice recognition, but the papers, the conferences, just to stand up and talk about it, it's also in front of your peers. It's something that we're proud of.
And that's something that you absolutely should be proud of, because first of all, I would never be able to design a battery to save my life. Like, I'm doing good if I get the plus and the minus in the right side. So, we're doing it there. But even then, like, it's not just like, even among your peers and other people who design batteries, like, it's something that is so like, to have a solution that everyone can kind of utilize and then also, take and improve on. And I feel like it just kind of brings everyone up and makes everyone better, because if someone's like, oh, you guys have this solution, well, why don't we have something like that? Like, how do I make something like that? And then it's just kind of that kind of you kind of reach that shared knowledge where everyone's just making each other better, and then ultimately, like, the entire industry benefits.
Yeah, you know, I totally agree. You know, you actually reminded me, one of the things that when we start talking about what the battery can do, and we get the, you know, like these, you know, light bulbs or, you know, bright eyes come out of our partners, like, wait a minute, you mean I can do this? Yeah, the Vatican, and then they started innovating around that. Like, okay, then that a lot, for example, in charging, charging cold weather is very difficult. But if you start heating it internally, you can then do stuff with charging power electronics. That's amazing. But they need the battery to know what the battery's doing and how it. So to enable that, we start working with, power electronics specialists that work on fast chargers, smart fast, and they were like, "Holy crap! Yeah, I can do this." And for vehicle, for example, when we work with people who work in very extreme conditions, I'm talking about above the atmosphere or really like underwater, and we show them what the Vatican's like. Okay, then I can do this, and some stuff is secret, but it's for our customers. But it is amazing, and I feel like we what the battery does, besides really powering innovation, it unlocks some of the constraints that allow our partners to do stuff with their system that the battery does that they would be amazed and we would like, my gosh, I know that the battery can do, but I didn't know the system can do this with the battery. So it is satisfying. You're absolutely right.
I feel like, have you guys, because like you said, it is very hard to get a battery to charge in cold. Have you guys come up with a solution? This is me just being curious. Have you guys come up with a solution for like ultra low cold things? Because like there's some cold storage warehouses that obviously have to be kept at like, and they have to go into like -30, -50 degrees Celsius, but like sometimes you have to still charge in that warehouse. And even though like the employees are wearing full protective gear, like, is there a solution for that?
Yeah, actually, that was one of the topics that we've been working on the last 2 years, and that was one of the recent patents we had, which actually one of it started with one of our customers had a forklift and some of the robotics that work into literally freezers to move stuff around. And they started having problems with the battery, and it was not, so we started looking at, okay, so when you buy the battery, actually, you cannot change the chemistry or the physics of it. So that's what it comes. And everybody knows in the industry knows that these batteries today have liquid electrolyte. And when you go below 0 Celsius, it freezes. So it limits a lot of stuff. So while you can actually, we found that our battery management system, we know what the state of the battery, so we can tell you can run it. You can discharge it up to -20, maybe 30, but charging is extremely difficult and dangerous. So if you charge a battery at below 0 Celsius, especially fast, it actually will explode, and that's a phenomenon because you start plating lithium metal, and that short circuit the battery, and bad stuff really happen. So it's very dangerous. So what we started looking, okay, how can I, improve in that? So we started, okay, well, I have to heat the battery. So we have a variety of ways to do it. And one of them came from an idea. Actually, I can talk about it now. 10 years ago, we worked on a project with Google called the Google Loon Project. That they send balloons up 100,000 feet, and it's very extreme condition. So we started using the battery to heat itself, literally, and our material can allow it to spread quickly. So when you're there, it's like, oh, okay, before it freezes, I can pulse it to keep it warm, and then I can charge it. So we started using these smart methodologies to heat the battery because you can discharge it, but you can charge it by pulsing it, by spreading heat, by heating the material, and allow the controller to actually to program that in the vehicle. So when they use it, they make sure before it hits there, they pulse it, heat it, and that way we were able to give it to our customers. Say, look, just put this in your controller. We add a little bit complexity. That's where our IP comes in, but we're able to do that, and that is fun. That is really fun.
That is so cool, but it's something that I mean, it seems so kind of easy of just like, oh, here's a pulse, here's a little thing, and it didn't require like reinventing an entire new battery solution. I feel like that has to be like I feel like on those days it's a huge win of like we solved a problem, we made everything safer for everyone, and we didn't have to spend like 2 years trying to rebuild a new battery or redo this, solve this problem from scratch. And I feel like that has to be like a really big win of a day.
Yeah, and I have to admit, we're not the only, group that does it. We just because we have this phase change composite that actually can store the heat and move it quickly inside the pack. So we can do that easily, probably. And like you said, without intrusive, we can just be more engineer around it. But I've seen a lot of other people who work with inserting heaters in the cell, people who are doing that. But the key to that is two things for us. One is unbelievable understanding of the electrochemistry of the cell to make sure that whatever you do, that does not damage it and push you to know what the limits are. But the second thing is being able to allow the customer to use existing infrastructure because, like you said, if they don't have smart charger, they don't have a sophisticated system, it will be very taxing for them or impractical. So we come to them, okay, what do you got? What do you got on the charger? What is the application? Do you charge it in the freezer or do you take it out? So we take all that in and then we use a combination of our IP and engineering to give them something that I would call literally number one, safe, number two, practical, and number three, it does not tax them on the cost of the battery or take away from the battery performance by diminishing life or diminishing performance.
I absolutely love that. It's like the epitome of meeting people where they're at to really give the best solution and work together. And I feel like that's a hallmark of any good partner is just like meeting you where you're at and then just kind of coming up with the solutions that you actually need.
Yeah, and that is our actually for the battery business that we have with the also being battery solutions. That's where we shine, as I keep saying that. That's where we position ourselves. Is if you want, cookie cutter battery, there's many people who can do that, and probably at some point they're better than us. But if you want a very expensive, space kind of battery that, goes into NASA, there's also people do that. Everything in between is a combination of making sure you can take off the shelf component, engineer around them, add some technology to make them do stuff that actually even the battery manufacturer sometimes is like, now how did you do that with our battery? They come and ask us, and we explain it to them because they're not aware that you can stretch it. I gotta give you one example, later about how we did something that even the manufacturer like, wait a minute, tell me more.
What industries are kind of the most like what industries do you guys service the most or at least see the most kind of complex adaptations for battery solutions?
Yeah, so if you look at our application right now, um, you will see that things that are, what I would call they need really the best performance of the batteries at the lowest weight and volume and some, shape. And that is something that, around innovation. So, for example, recreation vehicles, like, if you have an e-foil that, goes up, that is something that is not everybody can do this. What I would call like not the personal drones, but some of the commercial drones we do well. We've been working on eVTOL for the last 10 years. We've had some success early. Now we're going back and adding some really cool stuff around eVTOL for some of the fleet. And I'm going to give you an example. One of the biggest challenges of eVTOL, and we just presented this 2 weeks ago at MIT and at MIT Energy Conference, and we got, I got to brag a little bit. We got one of the top awards, Papers Award. And the concept was a few years ago, we noticed that if you're having eVTOL, which is electric vehicle takeoff and or air taxi, the economics of it limited by the number of trips. And the biggest time is when they charge it, it takes a few hours, sometimes 2 to 4 hours. And that is downtime because they cool it down to room temperature to charge it. And because when it takes off and comes back, it's hot. And we did a lot of research and we found actually if you charge the batteries when they're hot, it's actually good for them. They don't mind that because the diffusion, which is the lithium transport, is actually better at hot temperature. And the plating of lithium, which is when it becomes non-electrochemical, it becomes chemical, which is dangerous, is actually impeded at higher temperature. But the problem is you got to keep it within a range, like below 50 Celsius, so it does not cause damage or all that. And that's where we actually came up. It's like, wait a minute, don't cool it, keep it hot, control it, work with it. You can zap it. And with that, we started doing cell testing, and we just demonstrated that actually you can double the number of trips. Now, think of it this way. If you have a fleet and you cut the downtime or double the what's called the use of that per day, your economics go down from 7 to 5 years to 2 3 years. First so you're going to make a lot more money. Investors are going to love it, and it's going to be easy to scale this. And that's something that we were able to do just, to demonstrate in the last few months.
That is absolutely insane. But also, congratulations for coming home with some trophy there.
Yeah, they didn't give us money yet. Well, but they don't. Just,
Yet is the key word.
yeah, yeah. Well, I'm hoping our team here, our manager will buy some nice lunch one of these days. I'll talk to them about it.
So, Saeed, there's a question that everyone that comes on the show has to answer, and you're no exception. Is cereal considered a soup?
It's funny when I read that, the first thing that came to my mind, I have a son who's a high schooler. He's senior in high school, and he eats cereal, and every time that I was like, cereal can be anything. You just have to be a high schooler. And I stopped asking him about it. Like, okay.
Cereal can be anything. Honestly, high schoolers would probably defend that.
Oh my gosh, the way he eats it and the time, like, all right, I'm not gonna argue. I can swear to you that we would have a steak dinner and half hour later, like, yeah, I'm gonna have some cereal. Like, you're kidding me. Like, so, I stopped asking question about what cereal counts for. It's everything.
Okay, it's the end all be all. It's the solution for everything. Just throw some cereal at it.
It is. It is.
All right, Saeed, if anyone wants to reach out about other uses for cereal or if they have questions on batteries, where can they find you outside the show?
Sure. So if they can go to our website, beamforall.com, and we have a really nice, sections about batteries of thermal management, but we'll be happy, just reach out to us, and there's a contact info, and we'll be happy to respond and work with cool people like yourself.
Thank you. Well, thank you, cool person, for joining us. We only have the coolest of people on the cool show, on the Cold Chain show. Thank you so much for joining us.
It's a pleasure. Thank you very much.
You can catch other episodes of Running on Ice right here on FreightWaves TV, YouTube, or anywhere you get your podcasts like Apple Podcasts and Spotify. Need more Running on Ice news? No sweat. Subscribe to the newsletter on freightwaves.com/running on ice. See you on the internet.